Alright, so good afternoon and welcome to the GATE Academy. The GATE Academy, beta, all of you, Uma Shankar Tripathi would like to welcome you on behalf of the GATE Academy. So this is the score booster session and we are continuing the fluid mechanics score booster session. Before this session, we already had one score booster session of fluid mechanics. So this is the second session of fluid mechanics score booster. Good afternoon, Vijay. Good afternoon, Varun. Good afternoon, everyone. Good afternoon, Vinay. Good afternoon, everyone. So here we have completed our first fluid mechanics score booster session, and this is the second fluid mechanics score booster session. This is the second fluid mechanics score booster session. Okay. Now let me introduce myself. So since it is a second session, I'll keep it short. So my name is Uma Shankar Tripathi, as you can see on the screen, and we are here for fluid mechanics score booster session. Okay, so I am a PhD scholar at IIT Roorkee. Also, I have completed my Tech from IIT Roorkee, and before that, my GATE rank, if we talk about, so in 2014, I had 65.66 marks with AIR 916, and I had 76.02 marks with AIR. Good afternoon, Praveen. With AIR 643 in GATE 2015 examination. So in the previous session, I discussed the importance of 5-8 marks in our GATE examination. It can help in attaining very good rank, or it can even, if we are getting 5-8 numbers less in our GATE examination, it may reduce our chances to getting into some good place. Getting my point? So 5-8 numbers are very, very important. 5-8 numbers are very, very important as far as this GATE examination is concerned. So now let's see. I showed this yesterday also, previous session also. That's this fluid mechanics. So this you can see is the analysis of GATE 2012 to GATE 2020. That how many marks in which fluid mechanics is coming in our GATE examination. In how many marks this fluid mechanics is coming in our GATE examination. So it is coming somewhere near 8 marks. You can say 8 marks. If we take average of all these years, we can say that it is somewhere near 8 marks. So it is having a margin of 8 marks in our GATE examination. So my dear student, these 8 marks are very, very important. I told you in the previous session also, if I got 8 marks more in either of the year, either in 2014 or 2015, my rank would have been under 100. Okay, my rank would have been under 100. So this much importance a few marks have. This much importance 5-8 marks are having when we are preparing for the GATE examination. Beta. So in today's session, what we have completed in the previous session, So we have completed in the previous session, the fluid statics up to hydrostatic force on surfaces. Yes or no? Remember that? In the last score booster session, we had completed till this point. And before starting the today's session, I would like you to go through this formula sheet again. So we have this formula sheet we have covered up to this point. So in today's session, we need to start with this buoyancy. Yes or no? We have completed up to this point. So in today's session, we'll be shortly discussing about this buoyancy. Now here is the formula sheet. Now, what is buoyancy when it come into picture? This is a revision. What is the purpose of this session? So the purpose of this session is to boost our score. Means in this sessions we need to revise the whole fluid mechanics. Also we need to understand that while using which formula, what cares we must take. So in this topic buoyancy, there are two things, beta. Remember two things, beta. So in the formula sheet, as I have shown you, there is this first formula, that is FB is equal to W. That is FB is equal to W. So this FB is equal to W, what it suggests, that the force of buoyancy, the force of buoyancy is equal to the weight of the object, is equal to the weight of the object. Getting my point? Getting my point? Now here goes tip number one. Now, whenever we have a question of buoyancy, you firstly no beta, no, not when fully submerged only. No, there is nothing like that, beta. Now, listen to me very carefully. Now, when we talk about this topic, buoyancy, you always need to compare, or you always need to understand the concepts, by comparing with a ship. All of us, when I say ship, all of us can imagine a ship or not? Please tell me. Now, Varun, is this ship is fully submerged? Huh? Is this ship fully submerged or not? No, sir. No, sir. It is not fully submerged. Yes or no, beta? It is not fully submerged. So whenever we are seeing a ship in our mind, the trick is compare everything with ship. In this topic, compare everything with ship. So this ship we consider, we are imagining. So I assume all of us must have seen the famous movie Titanic. So all of us must have seen the ship. Yes or no? Yes or no? So will you consider your ship to be in floating condition, or it is in sinking condition? So definitely, sir, it will be in floating condition, sir. We will consider it in floating condition. Then how we will look at the ship? So we must look at the ship from the front. So if it is a ship, if this is calculator is a ship, so what you can see the thickness of the, means the height, the depth of the ship, and the width of the ship, and the width of the ship from front. Okay. So in front view, beta, what you can see? In front view, what you can see? In front view, sir, what we can see? In front view, sir, we'll be able to see the width of this ship, and we'll be able to see the depth of this ship. We'll be able to see the depth of this ship. Yes or no, beta? Yes or no? And as you said that we have the ship in the floating condition, not in drowned condition. So that means the water or the seawater or the fluid is not up to the top. It's not up to the top. So it is somewhere near in this height. Getting my point? Getting my point? Now, where will be the length of the ship? Where we can see the length of the ship? So the length of the ship can be seen. The length of the ship can be seen. If we want to see the length of the ship, I have to see perpendicular to the plane of the screen. No? Yes or no, beta? If we want to see the length of this calculator, we must see perpendicular. We must see perpendicular to the plane of a screen. Yes or no? So if in 2D I have to make it, I have to use another view. That we may call as top view. Yes or no? That we may call as top view. Yes or no, beta? That we may call as top view. That is L beta. That is L beta. Yes or no? That is L beta. Yes or no? All of you? Okay. Now this ship is in floating condition, means some part of it is immersed in the liquid. And answer, what is the key point here? What is the key point, beta? The key point is that when we consider now this highlighted FB into W, you need to use it almost all the questions of this buoyancy. Okay, so FB is equal to W. Now, what is this force of buoyancy? This is the weight of the liquid. Now, what is very important, that this is the weight of the liquid. Now, normally we get confused. Sometimes we get confused in calculating the weight of the liquid. So this buoyancy force, beta, this buoyancy force is the weight of the liquid. Getting my point? Is the weight of the liquid. So this buoyancy force we are talking about. So it is the weight of the liquid. So when we talk about this weight, so weight is equal to density into gravity into volume. So do always take care. do always take care, that this we are, do always take care that this we always remember to take the density of fluid while calculating the force of buoyancy, and this v is the displaced volume. This v is the displaced volume. So where we can make mistake in here, where we can make some mistake here, either we can make mistake in taking the density of the fluid or taking the volume which got displaced due to the object, now second thing, we need the weight. We need the weight of this object. So what will be the weight of this object? If this weight will be the density of the object. Anywhere you are measuring the weight of anything, it will be rho g into volume, yes or no? Rho g into volume, yes or no? So this volume is complete volume. This volume is complete volume, yes or no, beta? This volume is complete volume of this object, because you are finding the weight of the object. So here we have to use the density of the object. Getting my point or not? Danish yourself, please help me solving the amount of gold problem. What is that gold problem, beta? What is that gold problem, beta? Huh? Please tell me. So this is my complete volume. Now things to remember here. Now when we are using this FB, Shantanu, I'll tell you why we neglect buoyancy effect in air. I'll tell you. Just first focus here. Okay. Now here, firstly we have to take care while taking the density of the fluid, beta. While taking firstly the density of the fluid when we are finding this force of buoyancy, and when we are finding the weight of the body, we must take care of this density of the object. Now please tell me, beta, please tell me, if we have to use this formula, FB is equal to W. If we are considering the ship to be in floating condition, all we have to do is using that W is equal to FB. Now, what is this displaced volume? What will be the complete volume? It will be B into L into H, yes or no? And what is this displaced volume? So how much volume is displaced? It is displaced by this amount. It is getting displaced by this amount, which is equal to B into L into X. Now, if you equate them, you will be finding your X or not? Say yes or no, beta. Say yes or no. Will you be finding your X or not? Will you be finding your X or not? Yes, sir. If we equate these two equations like we have seen in the formula sheet, when we equate it, we'll be getting your X. We will be getting the X value. Once we can get the X value, we can have the center of buoyancy also, where this force is acting. Beta. This force is acting. Okay. Now in this score booster, what I want you to tell, whenever you are in each and every question of buoyancy, whether you are going to find the Metacenter or anything, you need to calculate both of them, W and FP. You always have to calculate both of them. Now, while calculating both of them, you need to take care of the densities, that you must take the right density at the right place. Secondly, take the right volume at the right place. You will be fine. If you do like this, you will be fine. Getting my point or not? Now, in the same order, let's do one question. Let's solve one question with that. Let us solve one question. So we can see a question. Let me copy it there. Then I'll take the doubts of Shantanu and Danish. Okay. Now see, I'm taking it here. Now you can read this question and try to solve it. Can you read this question and solve it? Please try to solve it. Please try to solve this question, beta. Please try to solve it, the question. What is the tip? What is the score boosting tip? In all the question, W and FB you have to do. W is equal to FB in almost all the question we have to do. Getting it or not? Now, when we do W is equal to FB, we need to take care about firstly the densities, secondly the volume what we are taking. Understood or not, beta? Understood or not? Now, Shantanu. Yes, Madhvi, this is for civil also, beta. This is common for civil and mechanical. Whatever there which is in mechanical, not in civil, I am not going to discuss here. Getting my point? All right. Now, Shantanu, you asked me, sir, do we neglect buoyancy effect in air? And if yes, then why? So, sir, we do not neglect the buoyancy effect in air if it is considerable. Now, sir, when it will be considerable? Now, we are sitting in air, yes or no? So, our body is also displacing some of the air or not? Our body is also displacing some fluid air or not? Shantanu? Shantanu? Now, since the density of air is very less, and we just have seen that the buoyancy force is the weight of the liquid displaced. Now, if the density of fluid, good afternoon, Ashwin. This is your first class, beta. So we'll try to make you understand the things. Just follow the session. Okay. Now, Shantanu, answering yours. So we are displacing some fluid which is air. Now, since the density of the air is very less, the weight of the air which our body has displaced is also very less or not? Is also very less or not, beta? Yes or no? Now, if the weight of the air we have displaced is also very less, so the buoyancy force acting on our body is also very less. Also very less. So, can we neglect it or not? Can we neglect it or not? Yes or no? Yes or no? But if we talk about a balloon, if we talk about a balloon, now balloon is also displacing some of the fluid, that is air. Yes or no? So when balloon is displacing some fluid, it is also acted upon by buoyancy force caused by the displacement of air. Now that small force, which is very small for us, will it be very small for balloon as well? No, sir. So in case of balloon, we can't neglect it. In case of ours, we can neglect it. Getting my point or not, beta? Getting my point or not, beta? All right. Now please solve this question, all of you. Please solve this question. Now see, this topic, this buoyancy topic is a very easy topic. Just only one formula, that is W is equal to FB or W and FB. Sometimes you have to equate it. Sometimes you don't have to equate it. Sometimes you don't have to equate it. Now in this question, as you can see on the screen, all we have to do is the force balancing. Now if I tell you one thing, let's say there is a body, just simple concept. There is a body, on this body, a force is acting downwards like this, a force is acting upwards like this, like this. So what will be the net force acting on this body in this direction? What will be the net force acting on this body? It will be W minus FB or not? You will say, sir, this is very easy, sir. This is very easy. The force line of action is same, their direction of opposite. As we know that the weight and buoyancy force acts in opposite direction, it will be subtracted from each other. It will be the subtracted from each other. Getting my point or not? Getting my point or not? Now, in this question, what they are asking you about that tension. They are asking you about the tension in the string. They are asking you about what, beta? They are asking you about that tension in the string. So, if we talk about the tension in the string, it will be the difference of this W and FB or not? It will be the difference of W and FB or not? What is the answer coming out to be? Please tell me the answer. Please tell me the answer of it. Score booster, score booster. Yes or no? Let's see if we can do it or not. Only one formula. In all the questions of buoyancy, we need to apply this formula, beta. We need to apply this formula, beta. What is the answer of this question? Please tell me. What is the answer to this question? Can you please tell me what is the answer to this question? Can you please tell me what is the answer to this question, beta? No. No. What is the answer to this question? What is the answer to this question? What is the answer to this question? Some of you are giving me some answers also. Very simple question it is. Many of you are not giving me the answer. Many of you are not giving me the answer. Many of you are not giving me the answer. Please, all of you, I request all of you. If you want a fast website, you have to try Hostinger. Please, all of you, give me some answer, beta. So, some answers are coming correct. Some answers you guys are giving is correct only. Some answers you guys are giving is correct only, beta. So, what answers you guys are giving? What answers you guys are giving? So, Harsh, your answer is incorrect. The answer to this question is 57. So many of you have given me the right answer also. Many of you have given me the right answer also, beta. Many of you have given me the right answer also. So what is the answer? Now please tell me. Now please tell me. What will be the tension in the string? In this tension, they are asking the tension in the string. So what will be the tension in the string, beta? What will be the tension? It will be the difference between. It will be the difference between W and FB or not. It will be the difference between W and FB or not. Yes or no, sir? Yes, sir. Certainly, it will be the difference between. Certainly, it will be the difference between W and FP. Certainly, it will be the difference between W and FP. Yes or no? Now, what is the weight? Now, what is the weight? Now, as I said, beta, as I said, while you are calculating the weight, all FB, always, always consider what that density. Always consider the right density. So you are calculating the weight of aluminium. So this is given, and also always take care of the units, beta. Always take care of the unit. So the unit is 25.83 kilonewton per meter cube. Means they have given you rho g combined. They have given you rho g combined into volume. Rho g combined into volume. So if we take rho g combined, it will be 25.83. And since we are getting the weight of the whole object, what will be the volume of it? It is a cube, so it will be 150 cube, 150 cube. Yes or no? Yes or no? So this will be the weight of this aluminium. This will be the weight of this aluminium, beta. Yes or no? This will be the weight of this aluminium. Yes, sir. It will be the weight of the aluminium. It must be the weight of the aluminium. Now, we say what is FB? What is FB? So you will say, sir, FB is the buoyancy force, is the amount of weight which is getting displaced by the immersed portion. So as you can see in this question, this body is displacing half of volume of S in oil and half of volume of S in water. Half of the volume of it in oil and half of it in water. So how many, if I say this buoyancy force is the buoyancy force caused by the displacement of oil plus buoyancy force caused by the displacement of water, will there be a problem in that? Will there be a problem in that? No, sir, there won't be a problem in that. Yes or no? No, sir, there won't be a problem in that. Yes or no, beta? There won't be a problem in that. Yes, sir, there won't be a problem. Now, if we talk about this FBO, if we talk about this buoyancy force of oil, so now always take care of what density you are using. So rho of oil into G, rho of oil into G into, and this is coming out to be kilonewton. So please take care of the units also. So how much volume it is displacing of the oil? So it is displacing half the volume. Half the volume. So it is 150 cube by 2. 150 cube by 2. Yes or no? Yes or no? And we must divide it by 1000 so that it can be converted into kilonewton. Always take care about units. Be very, very careful with the units, beta. Be very, very careful with the units always. Yes or no? Yes or no? Now coming to this FB of water, coming to this buoyant force by water. So sir, this is the weight. This is the weight of the water which is displaced. So this will be rho of water into G into volume into volume. So how much volume of water being displaced? So water being displaced by half the volume. Water is being displaced by half the volume again. So if we are taking rho oil, rho W, we can find our FB. Then we can make the difference between both of them, and then we can have our tension in the string. Then we can have our tension in the string, and that tension will come out to be beta. That tension will come out to be 57.71. Now, please tell me, is this question clear or not? Please tell me, all of you, is this question clear to you or not? Please tell me, is this question clear to you or not? Please tell me, all of you. Please tell me, beta. All of you, please tell me. Please tell me, is this question clear or not? Is this question clear or not? Tell me. Tell me. Now, all we have to do here, beta, all we have to do here is take care of the weight and the buoyancy force. Now, similar sort of question you can see in the GATE examination also. So, in buoyancy, what is our score boosting tip? What is our beta score boosting tip in buoyancy? That always remember to use the right density, right volume in case of buoyancy. In case of buoyancy question, getting my point or not? In case of buoyancy question, always remember to use the right density and the right volume. Yes or no? Yes or no? Yes or no? All right. So here we have used, so it is so rightly said, so 150. So what is the, so when we do like Shantanu, you are saying, sir, it should be area into 75. Area into 75 as half in this water. So same thing will come now, beta, isn't it? You are saying, sir, you do 75 into 150 into 150. Yes or no? You are telling me to do this, na beta, Shantanu. Anything else you are telling me? You are suggesting me, sir, do like this, है ना? Are you suggesting me that or not? Are you suggesting me this or something else? Please tell me, beta. Are you suggesting me this or not? You are suggesting me this. Now I have written 150 cube by 2. Aren't they the same thing? Aren't they same thing, beta? 150 into 150 into 150 by 2. So it will be 75 into 150 into 150. Yeah? Clear or not? Clear or not? Now let's see some of the GATE question that has been asked previously. Okay, so let's see. Just we don't have to do the GATE question here. Just see whether we can do it or not. Similar question, isn't it? Similar question, isn't it? Yes or no? Yes or no? Yes or no? Always remember that we are in statics. So in statics, all we have to do is this. Summation of all the vertical forces should be 0. All the vertical forces should be 0. All the vertical forces should be 0. So you will say, sir, we can do it. We can do it, sir. We can find the weight. While finding the weight, we will take the correct density. We will take the correct volume. Yes or no, beta? Yes or no? And while finding the buoyancy force, we will take the correct density of the fluid. We will take the correct density of the fluid. We will take the correct volume and we will make the difference of them. We will make the difference of them and give the answer. And give the answer. Yes or no, beta? Yes or no? Yes, sir. Yes, sir. Now see this question again. Yeah, similar question was asked in GATE 19 also. Direction, nothing we have to do with that. Direction, nothing we have to do with that. If F, see, W is acting downwards, FB is acting upwards. So if FB is greater than, W, what will be the direction of this tension? And if W is greater than FB, what will be the direction of it? What will be the direction of it? So accordingly, it depends. Getting my point? Getting my point. Now let's see one more question, beta. Let's see one more question. Same GATE question. Now in this question, what we have to do? I told you. What is my tip to you? What is the score boosting here? What is how when we are revising? What is our target here, beta? What is our target here, beta? Yes. Yes, the answer is D, beta. So what is our target here? What is our target here? What is our target here? That we want to revise, we want to do a quick revision of fluid mechanics, and also we want to go, this is what we have decided now in the first session, that we will go through each and every formula. We will see how we can memorize them, how we can use them. What are the do's and don'ts while using them? Isn't it? Isn't it? Now you please see this question on your screen and please tell me, will we be able to calculate or solve this question? Will we be able to calculate or solve this question? Please tell me. Will we be able to calculate or solve this question? Can you please tell me, Beta? Can you please tell me? Can you please tell me? Can we solve it? Can we solve it or not, Beta? Can we solve it or not? Can we solve it or not? So you will say, sir, yes, sir, we can certainly solve it. Sir, how we will be able to solve it? Sir, we know this is firstly in this concept of buoyancy will be applied. So if I say all the forces acting vertically downwards and all the forces acting vertically upwards, cumulatively they must be zero, as it is a static problem, as it is a static problem. Yes or no, beta? Yes or no, beta? You will say yes, sir. No problem, sir. Yes or no? Now, what are the weights that are asking upside down? So, in this balloon, there is helium. So, weight of helium will be acting upside down. Yes or no? Yes or no? Weight of the balloon will be acting upside down. Weight of the rope will be acting downwards. Weight of the rope will be acting downwards. Yes or no? Weight of the rope will be acting downwards. Yes or no, beta? Yes or no? This FB will be acting upwards, and all of them combined will become zero. All of them combined will become zero. Say yes or no. Say yes or no. Say yes or no, beta. Yes, sir. Yes, sir. We can do it. We can do it. So all we have to remember 2 points: right velocity, right volume, right density. So when you are calculating the weight of the helium, you must take the density of the helium. When you are calculating the FB, you must take the density of fluid which got displaced. The density of fluid which got displaced. Say yes or no, beta. Say yes or no, beta. All of you. Say yes or no. Say yes or no. Is that clear or not? Is that clear or not? Please tell me. Is that clear or not? Is that clear or not? Tell me. Tell me. Can we do that question or not? Yes, sir. We can certainly do that question. Yes, sir. We can certainly do that question. Now, coming to this formula sheet. Now, please tell me. Now, please tell me, beta. Now, please tell me. Can I say that this is clear to all of you? Can I put a mark here? Can I put a mark here? Yes or no? Now, in this buoyancy chapter, this is the first concept. And what I meant, I have written it in red. So, what does we meant by this red thing? What does we meant by this red thing, beta? What does we meant by this red thing, beta? Hmm? When we are writing it in red, what does we meant by it? What does we meant by it? Sir, we meant that this is something which is very important, very frequently getting asked. Remember that? Yes or no? Yes or no? Yes, sir. We do remember that. We do remember that. We will be careful here. Now, the second thing which can be asked in this buoyancy topic is your metacentric height. Is your metacentric height. So, if you see GATE previous year questions, you will find only, I think, one. Only one or two questions are there on this topic. I think only one question is there on this topic. So, that is why I have written it in blue. But it doesn't mean it cannot come. It doesn't mean it cannot come. So when we are revising our formulas, when we are revising our fluid mechanics, and as I keep telling you that the only thing is useful in the examination that is revised. Okay. So maybe you have learned fluid mechanics from me or any other faculty, yes or no? But whatever you have learned, you must revise it before your examination. So in this score booster session, we have targeted that we can quickly revise the things. Okay, we can quickly go through all the concepts we already have learned. So this is the formula of metacentric height. This is the formula of metacentric height. So what is, sir, this I? What is this I, sir? So I, we know, sir, it is moment of inertia. It is moment of inertia. What is this V, sir? What is this V, sir? It is the volume displaced. It is what, sir? It is the volume displaced. It is the volume displaced. What is this BG, sir? What is this BG, sir? So this BG is the distance this BG is the distance of center of buoyancy to the center of gravity, So this is x. This is x. Okay, this is x, and let's say this is h. This is h. Now please tell me where will be the center of gravity of it? Where will be the center of gravity of it? So we will say the center of gravity will mostly be on the center, geometrical center of this figure. Yes or no? So it will be somewhere here at G. And sir, where will be the center of buoyancy? So it will be at geometrical center of the volume of liquid displaced. So this is x by 2, this is x by 2, this is x by 2. So this is the distance between B and G. And I hope all of you can find it. Yes or no? Sir, yes, sir. Simply we can do it. It is h by 2 minus x by 2. It is h by 2 minus x by 2. So this BG is there. So BG is there. So if they are asking us to find the metacentric height, if they are asking us to find the metacentric height, metacentric height, we can apply this formula. The only thing to take care here, is what I, sir, we take. What I we must take, sir. We must take what I, sir. So let me tell you, beta. Let me tell you what we have seen, sir. What we have seen. This is our ship kind of a figure, na? This is our ship kind of a figure, na? Now, beta, you please tell me this. You please tell me this. Will your ship like this my hand, consider my hand like a ship. Now it is going. Now will it fail or will it sink like this, or will it sink like this? Which has more chances? This first motion, which we call as rolling, or the second motion, which we call as pitching? Tell me, tell me, tell me, tell me, beta. Tell me, beta. So definitely, sir, it has this tendency. Definitely, sir, it will have that tendency. Definitely, sir, it will have the tendency to sink like this. And sir, since it is more prone to, sink like this, we need to save it in this kind of a motion. And if it is saved in this kind of a motion, it will certainly be saved in this kind of a motion. Yes or no, sir? Yes or no, beta, all of you? Yes or no? Yes, sir. Yes, sir. So we have to take the moment of inertia. See, moment of inertia about this point. We have to take the moment of inertia about this axis, that is y. That is why if we are talking it as L, we are taking it as B. So we must use LB cube by 12 always. So why it is crucial? Why it is crucial? Why I am telling you it to be crucial? Because sir, whenever we see a figure like this, we are very much tempted to use this formula. Sir. I is equal to BD cube by 12. Are we or aren't we? Whenever we see a figure like this, we are very much tempted to use this formula. So if you use this one, it will be wrong here. It will be wrong here. Getting my point or not? Getting my point or not? Say yes or no. Say yes or no. Say yes or no. Please tell me. Will you be able to take care? Will you be able to take care? Will you be able to take care of moment of inertia? Yes. In Tom, yes. Rolling we say in Tom. All right. Similar way here. Rolling and pitching are the kind of a motion a ship have. Okay, Pranav. Okay, Vikas. Ashwin, please tell me all of you. Please tell me all of you. How to use this formula is clear or not? What care we must take while using this formula? Is that clear or not? Please tell me. Yes, sir. This is clear only. Yes or no? Can I place a tick here? Can I place a tick here? Please tell me. Please tell me. Clear to everyone or not? Clear to everyone or not? Now, if we do this question, now let's see one question. So if we see this question number 8, a rectangular pontoon. Pontoon is a ship. Pontoon is material carrying ship. Okay. Now, if you see this question, if you see this question, I believe, let me describe this question. Since it is a score booster session, see, I already told you I am not interested in making you calculate. Sir, put the values, give the answer. Give the answer. Okay, I am here not to boost your ego, but to boost your marks. Getting my point? Getting my point? Okay. So answers, in getting the answers, I am not very interested, but in giving you some concept, I am very interested. Okay. So that you can revise the things, so that you can get something out of this 2 hour session. Okay. Now please see, Vida. Now please see, if this is the question, a rectangular pontoon 10-meter long, 7-meter broad, and 2.5-meter deep, weighing 686.7 kilonewton. 686.7 kilonewton. It carries on its upper deck an empty boiler of 5-meter diameter. Empty boiler of 5-meter diameter, weighing 588.6. The center of gravity of the boiler and pontoon are at their respective centers along the vertical line. Now, what does that mean here? What does that mean here? That this boiler have this weight W1, and this is having this weight W2. This is having this weight W2, and you are required to find the metacentric height. You are required to find the metacentric height. Now, please tell me, for finding this metacentric height, what we require? We require I by V minus BG. I by V minus BG. So as I said, sir, this is H, this is H. And always one more tip, beta, this subject or any subject, your common sense will help you the most. Understand this. Your common sense will help you the most. Now, please tell me, this boiler is will be at the deck of this pontoon. Will it all be covered with water or not? Do you feel that this whole boiler will also be covered with water? What do you feel, Vida? What do you feel, Vida? What do you feel? Certainly not, sir. Certainly not, sir. We can imagine a ship, and the ship will be having water up to some X. This water will never be touching. This water will never be touching the deck. This water will never be touching the deck. Yes or no? So as I told you, the first step we have to do, in any question of buoyancy or meta center or anything, we need to find this X. So how we can find this X? So this FB we are seeing is equal to, W1 plus W2. Yes or no? The buoyancy force must be equal to the weight, or not? Must be equal to the weight or not? Now, this FB will be rho into G into submerged volume. Now, I said, please take care of the volume, and please take care of the density. Please take care of the units. You won't make a mistake. If you take care of these things. Now, unit is kilonewton per meter cube. So they have given rho g combined. Yes or no? Rho g combined, and we can use it W1 plus W2. Yes or no? So from here, can we get our X? Yes or no? Can we get our X or not? Say yes or no, please. Till this point, say yes or no. In this question, say yes or no. Say yes or no. Say yes or no in this question. Will we be able to find our X? Once we can find our X, we can half it, we can divide it by 2, and we can have our center of buoyancy also. Sir, we will get the location of this B. Now, in order to get this BG, you need to get the location of G also. Yes or no? Now, can you give me the location of G? Please calculate the location of G. Let's see if you can calculate it. Let's see if you can calculate it. Please calculate the location of G for me. Where will this G be located? How can we calculate the location of G? How can we calculate the location of G, beta? Now, to calculate the location of G, we can use one general formula, that is Y bar is equal to W1 Y1 plus W2 Y2 upon W1 plus W2 or not? Yes or no? Yes or no, beta? Yes or no? Since we have this W1, we can tell the location of this W1, where this W1 is from the bottom. Yes or no? It is at the geometrical center, so it is 1.25. It is 1.25. It is 1.25. Yes or no? Yes or no? This is 5 meter. This is 5 meter. So this will be, sir, this W2 will be 2.5 plus 2.5, that is 5 meter. Yes or no? 5 meter. Yes or no? Now, if we have where, what is W1, where it is applying, what is W2, where it is applying, so we can have where will be the resultant be applying. Yes or no? So can we put all these value and get the Y bar? This is the general formula which is applicable for weight, force, volume, area. Yes or no? If there are two forces, three forces, four forces, and they are acting at different locations, so their resultant will be acting. The concentration of their resultant will be, if we have to find, we have to use the general equation or not. Say yes or no, beta. Say yes or no. Ever seen this or not? Ever seen this or not? Please tell me. Ever seen this or not? Please tell me, ever seen this or not? Now, by doing this, can we find the location of G? Please tell me. By doing this, can we have the location of G also? The combined concentration of these weights, W1 and W2, say yes or no, beta? Say yes or no, beta? Please tell me yes or no. Please tell me yes or no, all of you. By doing this formula, by using this formula, or by doing this exercise, can we have the location, or can we have the location where this W1 and W2 both are concentrated? Say beta yes or no. Say yes or no, please, all of you. Yes, sir. Yes, sir. Now, the only thing is left. The only thing is left is this V and I. Sir, we have taken care of this BG. Now, what is this B, sir? So it will be 7 into X into 10. Yes or no? Displaced volume. Displaced volume. Now, please tell me what I we shall take. Please tell me what I we shall take. Okay? What I we shall take, and you can tell me in terms of D. Let's say the diameter of this boiler is D. Now, please tell me about this I. What I we must take. The only thing I want you to ask, because I know, you know, if you can calculate BG, you can calculate your moment of inertia, you can calculate your displaced volume. So I am very much certain that you will be able to calculate this metacentric height correctly. Please give me the answer. Please give me the answer. Please give me the answer. Now, because you are giving me 7 into 2.5. So, Vikas beta, oh, what's wrong, beta? What's wrong? I just told you not to use this. I just told you, beta. You have used BD cube by 12. You have used BD cube by 12. I told you not to use it. Not to use it, beta. I just told you not to use it. Yes or no? See here, and you are right away using BD cube by 12. What's wrong, beta? What's wrong? What's wrong? We cannot use BD cube by 12 here. We cannot use BD cube by 12 here. Getting my point or not, beta? What else? What else? Please respond. Those who are live, please respond. This session is for you guys only. Harsh, 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 you are giving me some answer. You are giving me some answer. Now see the score boosting tip beta, the very important tip beta, very important tip. So you just see, you just so the as you said, that's the moment of inertia we will take. We just established this fact that the ship will not be sunk. Now people will get confused. Are sir, this d is there. So shall we take pi by 64 d to the power 4? Or some people, some student will think to apply the parallel access theorem, will think to apply the parallel access theorem. No, sir, we don't have to do that also. Because this I beta, this I is the moment of inertia of the portion which is inside the liquid, which is inside the fluid. Getting my point or not? Now, if you see this plan, if you see the plan of it, if you see the plan of it, so its length, see, if this is a shape, this is the shape, this portion will be inside, this portion will be inside the liquid, this portion will be inside the seawater. Yes or no? Yes or no? So what moment of inertia shall we shall take? It will be lb cube by 12 again. That is why beta in the formula sheet what I have written, that is why I have written it here. That is why I have written it here, that no matter what, okay, just take the moment of inertia equal to lb cube by 12. Understood or not? Because this is the surface which is immersed in the liquid. Okay, do not get confused with this fancy questions, fancy figures like boiler is there, sir. Now we are tempted to. Whenever we see circle, what happened to us? I don't know. Always area. If somebody will say pi by 4 d square, I pi by 64 d to the power 4. I will have the concept right. Yes or no? Yes or no? Yes or no, beta? Will you make a mistake here? Can I place a tick mark on this metacentric height thing? Yes or no? Can I place this tick here? Can I place a tick here? Say yes or no? Yes or no? Understood? 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 Now, in this session, in our session, till what we have completed, till what we have completed. So we have completed now this complete fluid statics. Yes or no? Yes or no? Can we put a tick here now? Whole fluid statics is revised, and this is the biggest, fluid statics is the biggest topic in fluid mechanics. Now, beta Priya, fluid kinematics is there, beta, in civil engineering. So many questions are getting asked in fluid kinematics and civil engineering also. Hmm? We can have, you can see the GATE previous year questions also. Good afternoon, Ashwin. Ashwin, you are saying that BG is not clear to you. BG is not clear to you. Let's talk about this BG then. Let's talk about this BG. So BG is not clear in everywhere or in this question specifically. Are we talking about this question specifically, or sir, it is not clear? Yes, Shantanu, I already have taken. I already have taken. Priyad, see, in kinematics, what is kinematics, beta? What is kinematics? Kinematics is mostly continuity equation. Now, if dynamics is there, will continuity equation will be applied or not? Hmm? Dynamics is there in the new syllabus or not, beta, Priyad? Dynamics is there or not? Huh? If dynamics is there, you will have to apply the continuity equation, isn't it? Continuity equation is what? Continuity equation is what? It is kinematics only. It is kinematics only. Yes or no? It is kinematics only. All right. Now coming to this. Now Ashwin, you have the problem in this question or overall BG is not clear. In this question, it is not clear or overall it is not clear. With respect to this question, should I explain? Overall, it is not clear. Okay. Okay. Overall, it is not clear. Now, please tell me, beta. Now, please tell me one thing. Please tell me one thing. let's say this is some ship kind of a thing. This is some ship kind of a thing. And firstly, you please tell me, will it be completely immersed? Will it be completely immersed in liquid? So you will say, sir, no, sir. Jhansi, what you are telling me, beta? Book PDF. So it will not be fully immersed. It will not be fully immersed. It will be not completely immersed. So this will be my X. Now you please tell me, do we understand how to find X or not? Did we understand how to find X or not? Yes or no? Yes or no? Yes or no? Did we understood how to find X or not? Yes, sir. Now, if we can find this X, can we divide it by 2 to find the center of buoyancy? Please tell me yes or no. Please tell me yes or no. Yes, sir. So location of B is clear, beta. Location of B is clear. Location of B is clear. Yes, sir. Now, please tell me this G is center of gravity. So, if this is only body, this is H, this is H. So, center of gravity will be somewhere in the midpoint, somewhere in the middle, in the center. Yes or no, beta? Yes or no? Yes or no, beta? Clear? Is this clear? Okay, very good. Very good. Now, coming to this kinematics. Beta. Coming to this kinematics formula sheet. So let's now, so buoyancy is completed, beta. Buoyancy is completed. Where we were here. So this is our formula sheet. Okay. So our buoyancy is completed. Now let's move into fluid kinematics. Let's move into this fluid kinematics. Now, the first and the foremost thing in fluid mechanics, beta, is continuity equation. First and the most foremost thing in this fluid kinematics is continuity equations. So we will be seeing the equations. We will observe the formula. But before that, what is this continuity equation? See, the questions are coming of this continuity equation directly. No other concept is required. Only from continuity equation we can do. Now, continuity equation, beta, is what? So I'll give you what is continuity equation. If I ask student, people will say, sir, rho AV. Yes, beta, pipe flow is there. We'll be discussing it. Pipe flow is there for mechanical, civil, both it is there. Getting my point? We'll be discussing that. Now, please see. Continuity equation, if I ask some people, they will say, sir, A into V is equal to C. They will say, sir, rho AV is equal to C. They will give me this formula sometimes. Okay. So this is what continuity equation is. Yes or no? I also know. But what does that mean? It means that, beta, if there is, what is continuity equation? Let's say if 10 persons are entering a room and 5 are getting out. What is the number of persons which are inside this room? Can you please tell me? If 10 people are entering a room and 5 are exiting the room, what is the number of people inside the room? Definitely, sir, it will be 5. God is not coming to take anything. No alien is coming, sir. So this is what continuity equation simply means. That something which is entering, something which is exiting. So either what is entering must be exited completely, and if not, whatever not exited must be inside the room. If something entered, something exited, their difference will be there inside the room. Law of conservation of mass. Now, is it simple thing or not? Tell me, is it simple thing or not? Yes, sir. Quite simple, sir. Yes or no? Quite simple, sir. Now I want you to look at this question. I want you to look at this question. Now let's try and solve this question. Let me copy it there. Let me copy it there. Now let's first see if we can solve this question or not. Let's first see if we can solve this question or not. If we can solve this question or not. Can we see the question? Can we see the question? Can you please try to attempt the question? Now, before you attempt it, I want you, since it is a score booster session, and as I said, I want you to give as many as concept as I can, okay, as I can, so that complete utilization of your time will happen. Now, this is a container, my students. This is the container. This is the container which is telling that it is open to atmosphere. It is open to atmosphere. It is open to atmosphere. Now the discharge plug near the bottom of the tank is pulled out. Near the bottom of the tank means some plug was there. Some plug was there. So when plug was there, the water level will be maintained up to 1.2 meter. But as the plug is removed, but as soon as the plug got removed, this water will rush out of this reservoir or not? The water will rush out of this reservoir or not? Yes or no? Now they are telling that it will definitely rush out, and at some point of time it will become zero. Now you have to tell us, that when it will reach the level equal to zero point 0.6 meter, zero point 0.6 meter from bottom, 0.6 meter from bottom. Getting my point or not? Getting my point? Understanding the question or not? Understanding the question or not? Please tell me. Is this question understood or not? They have given the diameter of the stream also. Diameter of the stream also. They have given the diameter of this stream also. Okay. Now before we move ahead into it, now please tell me one thing. Once we open this plug, will it instantaneously reach from this point to this point? Will it instantaneously reach from this point to this point? Tell me. Tell me. No, sir. Tell me all of you. Tell me all of you. Will it instantaneously reach from the top to 0.6 meter height? From 1 to 1.6, it will reach? No, sir. No, sir. It will take some time. It will take some time. It will take some time. So can I say, yes, Jhansi, it is there for fluid mechanics, beta. Why I am saying, see, it may be not written in the syllabus, it may have been removed in the syllabus, but you see, dynamics is there, now Bernoulli equation is there. Now. When Bernoulli equation is there, you will have to apply the continuity equation. So kinematics is a study of continuity equation only, na beta? Yes or no? Yes or no? Understood? That is why I am teaching. Now this question, now you tell me, we are engineers, will somebody will write in the GATE syllabus, law of conservation of mass. Is it something to be written in the syllabus? Is it something to be written in the syllabus? Is it something to be written in the syllabus? Now, in this question, let me consider, in this question, at zero time, it is at this level. Let's say it will reach the 0.6 meter level in T time. It will reach 0.6 meter level in T time. Getting my point? Now, does it look like we have to arrange? we have to make arrangements. We have to make arrangements for integration. This is something. This is something we require integration to do. This is something in which we require to do the integration thing. Yes or no? This is something in which we require to do the integration. Yes or no? Please tell me. 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 Now, simply what we can do. So, firstly, if we say the law of conservation of mass, so mass which is coming in this system, mass which is getting out in the system must be equal to the rate of change of mass. The rate of change of mass. Yes or no? Say yes or no. Say yes or no. Tell me. Tell me. Is this something? This is something what we have seen that 10 people and entered, 5 people exited, so 5 is left. So with something which is coming in minus something going out, so at that rate only the mass will increase inside this, or the mass will change inside here. Yes or no? Now no mass is coming in from outside, only it is getting out. Only it is getting out. So do we know it is rho area of jet into d of jet? Yes or no? Sorry, into v of jet, or velocity at exit. Yes or no? Please tell me. Please tell me. Please tell me. Is equal to dm by dt. So what is the mass if at some instant I am writing it at some dt, at some instant, if the height is h, this will be rho into area of tank into h upon dt. Yes or no? Yes or no? Please tell me yes or no. How I have written this equation, is that clear or not? Is that clear or not? How I have written this equation, is that clear or not? Is that clear or not? Please tell me. Is that clear or not? Is that clear or not? Now, sir, can we say we all have seen this Bernoulli equation? We all understand this Bernoulli equation. Now, if I say from Bernoulli equation, if the velocity of the exit is root 2gh at some instant of time, if we calculate the velocity, it will come out to be root 2gh. Sir, how, sir? How, sir? Array, this is something we see from the Bernoulli equation. See, if there is a tank like this, if there is a tank like this, if there is a tank like this, and this liquid, this liquid, this liquid is getting out. This liquid is getting out from here. So what will be the exit velocity? What will be the exit velocity? So if this is h, from Bernoulli equation, this exit velocity come out to be root 2gs. This is something, same thing I am using there. This is the same thing I am using there. Say yes or no, beta. Say yes or no. Say yes or no. Now, once we get an equation like this, what we can do, sir? What we can do? So we can put all the values. We can put all the values. We can take dt at one side. We can take dh at one side. We'll put all the values containing h, and we can integrate it from 1.2 to zero point 0.6, and we can integrate it from 0 to t. We'll be getting the t or not? We will be getting the T or not. Now, will you be able to do the integration? How to approach these kind of a questions? Understood or not? How to approach this kind of a question? Is that understood or not, beta? Is that understood or not to everyone? Everyone? Yes or no? Yes or no? Yes, sir. Yes, sir. Understood to us. Understood to us. Now, let's go to the formula sheet again. Now, do you feel, guys, do you feel this session is helping you or not? Yes, certainly we can do the complete integration also if you guys want. But if you feel that we can do from here and we can move ahead and can get some more good concept, then it's up to you. So one more step if you want to do, so it is minus rho area of jet. So you use the diameter of jet here, diameter of jet whole of a square. Okay, velocity of exit root 2 gh you may place. Okay, is equal to rho is constant, is equal to rho is constant, area of tank is constant. So area of tank, to find the area of tank we must use pi by 4 diameter of tank whole of a square, that is a area of tank, into dh by dt, into dh by dt. So you can write it this way, that dt is equal to, now this pi by 4 will be cancelled out, rho will be cancelled out, it will be d of tank upon d of jet whole of a square, whole of a square by 1 by root 2g and 1 by root 2h dh. Then we can integrate it. Is that clear or not, beta? Is that clear or not, beta? Is it clear or not? Can you please tell me, is it clear or not? Is it clear or not? Final expression? Tell me. See, in general, I am talking to you in this subject or in any subject. Always, whenever you are preparing for integration, just send all the variables one side and the other side. With dh, send every, if there is dh. See, if you have to integrate, now dh is here. So send all the spices, all the values, all the variables containing h here. And if you are integrating with respect to t dt you are doing, then send all the things containing t here. This is the general way. This is the general way. Getting my point? Now let's come to this formula sheet. Now let's come to this formula sheet. So general continuity equation, general continuity equation, general continuity equation we understood. General continuity equation, the use of it with the that question was not a question of fluid mechanics at all. That was a question of common sense, I must say. Mostly common sense. 90% common sense, 10% fluid mechanics. Yes or no? Yes or no? For that, we must understand that when to use the integration thing. Otherwise, you can't do it. Otherwise, you can't do it. Then, sir, how we will just, sir, when to do the integration? So that question, why I opted, why first thing came in my mind that we have to make preparation for integration by this fact that distance, that it is decreasing gradually, not instantaneously. It is decreasing gradually. So in dt times sum, it's often increasing. So I always tell you this thing in my class, whenever you say some variation, whenever you say see the variation, you always make arrangement for integration. Always make arrangement for integration. Now, moving ahead with this formula sheet, this is the generalized continuity equation. So I have written it in black because sometimes it is asked to identify only, because coming numerical from it, it is a little unlikely. Okay, but you have to memorize it. You have to memorize it. Now, this is very, very important. This is very, very important. Continuity equation for a steady and incompressible flow. This equation is this. This equation is this. Okay, del u by del x plus del v by del y plus del w by del z, del w by del z. Now here goes some tips to you guys. Okay, now in the chapter of kinematics, so when we say the kinematics, when we say that the kinematics, so we have to talk about velocity. Kinematics means talking about the motion. So what comes into this motion category? What is something which comes into this motion category? So velocity, acceleration, angular rotation, which we call angular rotation, means angular velocity, we may say. which we generally use term as omega, angular velocity, then vorticity, and then circulation. Now, what do we mean by kinematics? So, what do we mean by kinematics? So, we mean by kinematics that we have to talk about these factors. We have to talk about all these factors, which I now going to encircle with this green color pen. So in kinematics, we have to talk about these things. We have to talk about these things. Now, to talk about these things, please understand. Now, to talk about these things, we have two kind of inputs. One is vector input. Now, in general, if I talk, not in engineering, we are studying from the first class in our educational system. Whenever we have a question, we have something given to us. No, yes or no? Please tell me. Whenever from class 1 onwards, we are bombarded with questions from the very first class in our life. So whenever some question is there, there will be something given to you. Huh? Yes or no? Do you agree to this fact or not? Yes, sir. Yes, sir. There will be some input. Now, in this topic, please observe the input and proceed accordingly. This is the tip. This is the tip, beta. Please observe the input. Please observe the input and move accordingly. So, if in the given question, the given data is in the form of vector, is it in the form of vector? Then how to proceed? And if it is in the form of scalar, if it is in the form of scalar, then what will be the form of input? So the type of question, the types of question that you are going to see, is in which you will be given some data like this. Some data like this means that things will be given. IJK will also be given. When IJK is given, this is something which is we are calling like a vector. Yes or no? Yes or no? And there will be type 2 questions. There will be type 2 questions in which the input will be given in terms of a scalar function. So how to identify a scalar function? How to identify a scalar function? How to identify? So how we will identify, sir? We won't be able to see terms of IJK. These vector operators we will not be able to see. These vector operators we won't be able to see if the input data is in the form of a scalar. And here in this vector, U, V, and W all are also the function of space and time. All are also the function of space and time. ये सब क्या होंगे? All of them are the function of space and time. Getting it or not? Getting it or not? So ultimately, either the input is in this form, we have to go and find all these. We have to go find all these. Getting my point or not? Please say yes or no. Getting my point or not? Say yes or no. Okay. Then, in order to do that, see, so I have written these 4 things. I have written this 5 things: velocity, acceleration, angular velocity, vorticity, and circulation. Let's name them. Let us call it A. Let us call it omega. Let us call it zeta, and let us call it gamma. Okay. Let us call it gamma. Okay. Now I tell you what. If I have this, if I have this U, V, and W, I'll be from using formula, by using formula, we can reach to acceleration, we can reach to omega, we can reach to zeta, we can reach to this. Now, sir, from where we will find this UVW? Once UVW is found, all this will be found. All this will be found by using simple formula that we are going to see. Now, if input is like this, we are okay. UVW, all 3 are given, then no problem. We will directly use the formula. we will directly use the formula. Now, if UVW is not directly given, what shall be the first approach? What should be the first thing you attempt to do? What should be the first thing you must attempt? Yes or no? Yes, Rahul. Yes, Rahul. We can calculate all these from this velocity components UVW. Now, please tell me, if UVW is not given in the question, what shall be your first approach in the question? Firstly, what you must try to do? Please tell me that. Please tell me that. First of all, what you must try to do? We must try to find U, V, and W, yes or no? And something will be given now. Something will be given. So we must diverge our concentration on this UVW, isn't it? Yes, Vijay. Obviously, we must find UVW. We must find UVW. Yes, Shantanu, there could be many possible ways of finding UVW. Okay. Now, for finding this UVW, most of the times, we require to use this equation. This one, this highlighted one, this one. Okay. Now, you please tell me, if I give you U, if I give you like U, XY, 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 if I give you V, let's say X square, Y square, and if I ask you W, what is this W for? Is steady and incompressible flow, and this is also valid for only incompressible flow. This equation can also be used for only incompressible flow. Only incompressible flow. So if U and V will be given, will you be able to find your W by differentiating and then integrating? Yes or no? Yes or no? Yes or no, beta? Shantanu, kinematics is the simplest topic we have. I'll complete it in 15 minutes. 15 minutes I'm going to take and it will be completed. Tell me, all of you. Tell me. Tell me. So yes, sir, we will be able to find the W. We will be able to find the W. Yes or no? We will be firstly differentiating partially U, V with X and Y. Then we'll be integrating them with respect to Z. We will have our W. Once we have our W, then we can take care. We can see some formulas that we are going to see today. Okay. We are going to see today. But the thing is, firstly, I want you to understand that I want UVW. I want UVW. Now, the kind of question, if UV is given, can you find W? If UW given, can you find V? If VW is given, can you find U? Say yes or no, beta. All of you. All of you. This kind of a question can we do or not? This kind of a question can we do or not? This kind of a question can we do or not? Tell me. Tell me like this. Like this. Let's see some gate questions based on this. We are not going to solve it. Now here in this question, irrotational also they are asking that we are going to see how to judge whether the flow is irrotational or not. But how to check whether this is compressible or incompressible? Can you tell me? Can you tell me? How to check whether it is compressible or incompressible? So you will say, sir, firstly, sir, this is two-dimensional. How, sir? How it is two-dimensional, sir? How it is two-dimensional, sir? Because only U and V components are there, I and J is there, I and J is there. So if it is two-dimensional, we can certainly use this equation. And we can check. So we can put all this U and V in this equation, all this U and V in this equation, and we can see if it is coming to be zero, if LHS and RHS are getting, equated. Why we will need double derivative, Rahul beta? No need of getting double derivative. Beta, options are not correct, beta. Options, do not see the option. This is typing error. This is typing error. Okay. Okay. This is the typing error, beta. These are not the options of it. Getting my point? Getting my point? So you have given me option also. In this, they are asking compressible or incompressible, beta. Okay. You have considered this. Okay, very nice. You must have considered this option. Right. Very smart of you. Good, good, good. Okay. Now, irrotational we will see. Irrotational we will see. But please tell me, if we have to check whether the flow is incompressible, is steady, unsteady, or what, will we be able to do this kind of a questions or not? Say yes or no, please. We need not to solve it, beta. Rahul, see here you and we are directly given. So what you are telling, I understand. You are saying that, sir, if a Laplace equation is satisfied for potential function, it is a case of incompressible flow. But you please tell me why firstly we'll go and find the potential function, then check if we can directly check. That observation you are telling me, Laplace equation, double integral equation, that observation is coming from this equation only, Namita. So why we first go and find the potential function, then check if we can directly check. All right. So we can, if we have the value of UVW, we can certainly check that whether the flow is steady, incompressible, and vice versa. If a steady, incompressible flow is given, we can find some variable, as you can see in this GATE question. Similar question getting asked in recent years also. This is a 1995 2 marks question. This is a 1995 2 marks question. Now, can you tell me? Yeah, Rahul, no problem, beta. Very good. Now, please tell me, can we solve this question, beta? Can we solve this question? All of you, please tell me. We need not to solve this question right here. This is a GATE question. We need not to solve it. Just, I am trying to tell you, because our purpose is to make you revise all the formula. You are giving your 2 hours for this session. So in 2 hours, you must revise almost 3-4 topics, almost 3-4-5 chapters. You must, revisions of yours must be done. All right. And please also please like and subscribe the GATE Academy also, na? If you are liking the session. All right. Now, can we solve this question? Yes, sir. Certainly, we can solve this question. In this, it is given that the flow is incompressible. So what have to do? What we need to do? We need to apply this formula. We'll be put it equal to 0. We have this lambda. So this lambda will be calculated. One equation, one variable problem it will be. So the lambda will get calculated. Is that clear or not? Please tell me. Is that clear or not? Please tell me. Is that clear or not? Is that clear or not? Please tell me, beta. Please tell me. Please tell me, all of you. Yes, sir. That is clear only. We can do this kind of a questions. Okay. Now, please tell me, by use of this equation, will you lead to UV and W? Will you lead to UV and W? Now, as I said, if you have this UVW, you can calculate everything. Now, from UVW, if you have input UI Vj plus Wk, if this is given to you, or you have UVW, now from using this formula, can you calculate your accelerations? Namaste, Randir. Can you calculate your accelerations? Say yes or no. Beta. Say yes or no. Now, so this formula is looking like very lengthy, sir. This formula is very lengthy, sir. How we will memorize it? So this is very easy. To memorize. See, we need to calculate acceleration in x, acceleration in y, in acceleration in z. Now, what is the component of velocity in x? It is u. So write like this. We will straight away memorize the formula also. Write like this: del u by del x plus del u by del y plus del u by del z plus del u by del z plus del u by del t plus del u by del t, and it will be u plus v plus w, like that. Just very simple, very simple. Now in the direction of y, the velocity is v. How to write, sir? How to write v everywhere? Write v everywhere. Write v everywhere. Like this, like this, like this, and then do u, v, and w. U, v, and w. In the same way, you can calculate. In the same way, you can have that w also. So this is v, this is v. Now, is this formula memorized right away or not? Please tell me. Is this formula memorized right away or wrong? Not. Tell me. Is this formula memorized right away or not? Tell me. Tell me, beta. Tell me, beta. All of you. Yes, sir. This is right away memorized. This is right away memorized. Okay. Now, if we have UVW, we can put the values, we can do differentiation, we can find all these acceleration components, and we know, sir, acceleration is a vector. So it may also be written like this. It may also be written like this. Yes or no? It may also be written like this. Yes or no, beta? Yes or no? Please tell me. Yes, sir. It may also be written like this. Now coming to this angular velocity omega. So again, you can see if we have UVW from the formulas, we can find them. If we have UVW, can we find omega x, omega y, omega z using this formula? Say yes or no. Mahinder, this is vector beta, not total acceleration is not there. You can find the resultant of this acceleration at any point. How to find the resultant of any vector, not just acceleration, any vector in the direction I, j, k, you can find your resultant like this. Yes or no? Yes or no? So here also you can do the same thing. Total acceleration, we may not add it. But there are questions of acceleration in the previous years, Shantanu. 2 questions are there. Not one, 2 questions are there in GATE. In GATE. They are not very frequent. That is, I have written them in black. Okay. When I use this red color, when I see that the more questions are getting asked, the angular rotation parts, but a lot of questions are there. Lot of questions are there. You have to find the vorticity, you have to find this. 2 questions of vorticity itself has been asked. Many questions are asked to judge whether the flow is rotational or irrotational. How you will check? You will check by finding these only. Yes or no? Yes or no? All right. Now, again, now first tell me, all of you, please tell me if we have this UVW, if we can make arrangement for this UVW, we have our omega x, omega y, omega z. Will we be able to find omega x, omega y, and omega z or not? Yes or no, sir? Yes or no, sir? Yes, sir. Yes, sir. But sir, these formula looking like very tedious to us. How to memorize this, sir? How to memorize this? So this is also very easy to memorize. They just look big. They are very easy to memorize. How, sir? How we can memorize, sir? How we can memorize, sir? So if this is x, this is y, this is z. So see, remember this sequence. And will it burden your mind to memorize or remember the sequence x, y, z? Correct? A, B, C, D, E, F, G, H. Does it take any pain in our mind to remember this sequence X, Y, Z? Remember this sequence X, Y, Z? No, sir. Yes, Vijay, it is half curl or V. But I am giving a shortcut of so curl, you will write the curl, you will write the matrix, you will make the determinant. So I am giving a shortcut. If you like it, you can use it. Otherwise, you can ignore it. So we want to write about X. We want to write about X. So remember this half. Half you have to remember. That half is there. Okay. Now, after X, what is coming? Y is coming. After Y, what is coming? Z is coming. After Y, what is coming? Z is coming. Now, the component of Z velocity will come here. The component of y velocity in the direction y will come here. Similarly, I want to write omega y. I want to write omega y. So it will be half. So after y beta, what will come? After y, sir, z will come. After y, z will come. After z, x will come. After z, x will come. The component of velocity in the direction of x, we can take it as u. The component of velocity in the direction of z, we can write like w. Similarly, z, sir, after z, what is coming, sir? After z, what is coming, sir? It is coming out to be delta x. It is coming out to be delta x. It is coming out to be next is delta y, x, then y, the component of y here, the component of x here. So this is the way I memorize it. Okay, Shrikant. Now you can see me live also. Recordings also you can see in the LMS. But here we can see each other live also. All right. So from this, if we have UVW can simply we can find this omega x, omega y, omega z also. Simply we can find omega x, omega y, and omega z also. Please tell me yes or no. Please tell me all of you yes or no. Please tell me yes or no. Please tell me yes or no. All right. All right. Now we see questions like whether tell us the flow is rotational or irrotational. Okay. So if flow is irrotational, if flow is irrotational, if flow is irrotational, this omega x, omega y, omega z all are zero. Omega x, omega y, omega z all are going to be zero. Got it or not, beta? Got it or not? Please tell me, got it or not? Yes or no? Yes or no? Now, if we have this omega, we can simply find this vorticity. We can find this vorticity. How to find, sir? Just multiply 2 into this rotational vector. You want to find the vorticity in z direction? Just do 2 omega z. Just do 2 into omega z. Getting my point or not, beta? All of you, getting it or not, beta? So if we can find this angular rotational vector, we can find our vorticity numerically. Yes or no? Very simple, sir. Very simple. Similarly, if we want to find this circulation, we can find it through vorticity by multiplying it with the area. A is the area here. So you find the vorticity, some area is there, some area is there, some area is there, some area is there. You can multiply the area into vorticity to get the circulation. Now, Shantanu, you are asking, sir, why Z only? So you can see rotation. Now, see, please tell me, this is X and this is Y. How many planes are there? How many planes are there, beta? Shantanu, how many planes are there? You please tell me how many planes are there? One plane is there. Now you please tell me rotation, because it is one plane, but directions are two. Yes. Area is line integral closed curve area. Yes. Yes. But if, see, so because the directions are two, the plane is one. Now please tell me, rotation take place in direction or in the plane? Which is the right sentence to say that rotation taking place in x direction or rotation taking place about x direction in x direction in yz plane? Rotation takes place in plane or in direction? Please tell me that. Please tell me that, beta. Please tell me that, beta. It happens in plane and about the axis. About the axis. So when you are saying that vorticity or omega in Z, you simply omega Z means what? That you are talking about XY plane. So in two dimension, if nothing is given, we generally take XY plane. If y is there, so it means xz plane. Is omega x is there, it means yz plane. It means yz plane. So there is nothing like that always we need to calculate about z. If nothing is given, you can calculate about z. If something is given, you can calculate about that axis. Getting my point or not? Getting my point or not? Yes or no? Yes or no? Yes or no? Now this circulation, as you are telling, this area is the area under the closed curve of this line integral. Now please, I tell you one thing. We know there is a subject named mathematics or not? Do we know? Yes, sir. We certainly know, sir. We certainly know. Do not embarrass us. Yes or no? Yes, sir. We know mathematics. There is a subject mathematics. Yes or no? In that mathematics, there is a topic named as vector calculus. So I tell you, this whole kinematics is nothing but a kind of easier version of that vector calculus. Or I must say, it's a kind of very trivial application of that vector calculus. If you remember in mathematics also, you see this rotational, irrotational in mathematics also. Those who are studying electronics are also seeing this question. They are also learning that if curl of any vector is 0, it is called as irrotational. Getting my point, beta? So in line integration, we have this circulation is coming from that line integration. Okay. But as far as this kinematics is concerned, we can find the vorticity the way I told you, and some area will be given in the question. You multiply that area with this vorticity, you will have your circulation. Got my point or not? You will have your circulation. Got my point or not? Yes. Yes. Stokes theorem in 2D. It is called as the Stokes theorem in 2D. Yes. Rahul, that dx dy, see, line integration is a different business. Okay. It's the score booster session. We can't get into that. See, I tell you, I make you remember one thing. When we study this vector integration, the volume integration is the easiest one. Area integration is the second, means is slightly harder than the volume integration, and the line integration is the most hard one. Yes or no? We mostly solve the question by changing the line integral problem into area integral problem, and we solve mostly area integral problem by changing it into volume integral problem. Is it or isn't it? Yes or no? Yes or no? So for just this quick review, all we can do, just remember this, sir. If vorticity we can find, just multiply it with some area. Some area will be given in the question. Multiply it with the vorticity. You will have your circulation. Now, can we see some questions here? Now, on the basis of that, I want you first to do this question number 2. Solve this question number 2. Solve this question number 2. Then we'll do this question number 3. Okay. So this is pi a square. This is minus 12xy pi a square. This is also xy. This is y. Okay. Now first solve this question number 2. Let's see if we can solve this question number 2 or not. Question number 2. Let's see if we can solve this question number 2 or not. What is the answer to this question number 2? Can you please tell me what is the answer to this question number 2? Can you guys please tell me? Now, please tell me what is this stagnation point? What is this stagnation point? What is this stagnation point? So, what do you mean by this stagnation point? In dynamics, we go through this stagnation point. So, what is this stagnation point? Point of zero velocity, or we can say point at which complete conversion of kinetic energy into pressure energy take place, point at which velocity is zero. Yes or no? Yes or no? Yes or no? Now, if it is the point at which the velocity is zero, it is the point at which the velocity is zero. At this point, u must be equal to zero, and v must also be equal to zero. Yes or no? Yes or no? So u is equal to 0 means 0.66 plus 1.3 of x is equal to 0. And this is minus 2.7 minus 1.3y is equal to 0. Say yes or no? Say yes or no? From these two, from these two, from these two, can we find the x and y? From these two, can we find our x and y? Say yes or no? Say yes or no, beta. Say yes or no. Yes, sir. Yes, sir. We can find, sir. Yes, sir. We can find. So if you find, you will be getting option B. Now I want you to do this question. Question number 3. Let's name it question number 3. Let's call it question number 3. Can you please solve it? Just give me a moment. I'll rub all these things. Okay. Now this question number 3. Can we attempt this question number 3? Can we attempt this question number 3, please? Can we attempt this question number 3 or not? Let's try to attempt question number 3 now. Let's try to attempt question number 3 now. Let's try to attempt question number now. Can we do it or not? Can we do it or not? Please tell me, can we do it or not? Please do it. While you are doing the question, please also like and subscribe the GATE Academy channel. Also, if possible, share to your friends. Yes, Rahul. Yes, you are right. Yes, Prince, your answer is also right, beta. Your answer is also right, beta. What about others? Please answer. Shantanu, Vikas, Pranav, Vijay. All other students, please also, you also please answer. From the options, yes, Rahul, from the option, there is no need of this circular equation. Now, you are asking me, sir, what is B? It is minus 6 square Y. Now, from this, can we get our zeta Z? Sir, why we are getting zeta Z? Because see, U and V are given. So, component of velocity is given in X and Y direction. So, rotation will take place, rotation will take place, rotation will take place in XY plane, that is about Z. That is why we are using zeta Z. So, it will be half del by del X minus del by del Y. Same way we have to write the equation. Same way we can write the equation. Now, if I say this del v by del x, if I say this del v by del x is minus 6 to 12xy, is minus 12xy, and this is 0, will there be a problem? Will there be a problem? And this is zeta z I am writing, so I must multiply. This is omega z, so I must multiply it by 2 also. I must multiply it by 2 also. So our zeta z is coming out to be minus 12xy, minus 12xy. Now here in this question, this equation of the circle is given. The equation of the equation of the circle is given. The equation of the circle is given. Now from this equation of the circle, what will be the radius? The radius will be a. The equation of the circle will be x square plus y minus a square. Yes or no? Yes or no? Yes or no? See, Rahul, I deliberately arranged that options. I kept pi a square in each of them. Why is it so? Because, sir, I didn't want you, some people will get confused also, that how to find the area of the circle from this equation. Getting my point? Getting my point? Now, Harsh, you are saying, sir, why you are taking about Z? Now, U is the, now here in this question, U and V is given. Na? U is the component of velocity in X direction, V is the component of velocity in Y direction. So we have these two direction, X and Y. X and Y. So our rotation will be taking place in XY plane or not? So this rotation will be about Z or not? That is why I have taken about Z. That is why I have taken about Z. Got it or not? Got it or not? Say yes or no. Say yes or no. Say yes or no. Now, in this formula sheet, can we say, where is the formula sheet? Okay. So this one is yours. Okay. So can we say up to this point it is clear? Up to this point it is clear. Can we put a tick everywhere? Yes, sir. This is also clear. This is also clear. This is also revised. This all is also revised. Say yes or no. Say yes or no, beta. Say yes or no. All of you. Say yes or no. Now, as I said, now as I said, the other way to give the data could be of a scalar form, In what form? A scalar form. So they can give you a potential function. That potential function, we call it phi. We call it as phi. This phi is a function of x, y, z, and t again. Okay, so from this phi, you can simply use these equations. You can simply use these equations to get UV and W. Now, please tell me from phi, if you can get UVW, all the things what we have seen, circulation, vorticity, acceleration, omega, all will be dull or not? Shantanu, in the last problem, beta, all we have done, we have find this omega z, then vorticity, then multiply it by the area. So in that last question, the area of the circle equation was given. The equation of the circle was given. So the equation of the circle was given. We found this radius. We used the area of it. Just that. Just that. Nothing else. Just that. Understood, beta? Now, if we have this phi given to us, can we get our UVW? And once we can find our UVW, every other thing we can find, yes or no? Similarly, there is one stream function also. Similarly, there is one stream function also. Similarly, there is one stream function also. A stream function again is a function of space and time, that is x, y, z, and t, and it is again a scalar function. Now, what do we mean by scalar function? That it do not have I, j, k in it. It do not have I, j, k in it. Now, from this stream function, now stream function we can see in two dimension. In two dimension. Now, sir. Now, sir. Firstly, sir, how to memorize this one? This is very easy to memorize from potential function. How, sir? Array potential function. If you differentiate in any direction and put negative before it, you will be getting the velocity in that direction. Yes or no? It is defined that the potential function, the negative derivative in any direction will give the velocity in that direction. Negative derivative in any direction will give the velocity in that direction. That is what we know as the potential function. Okay. Now, in this stream function, you observe the formula. In this stream function, it is also, which I am explaining why negative. So it is also very simple to understand. See, if we are differentiating this stream function with x, we will be getting the velocity in perpendicular direction from the x. Getting my point or not? Say yes or no. Getting my point or not? Say yes or no. Say yes or no. Say yes or no. First thing is this. If we are differentiating with respect to y, we will be getting the velocity in perpendicular to that of the y. That is u. Perpendicular to y is u. Is it or isn't it? First thing is that. Now the question is, sir, why you have used negative here? Why you have used negative here? So because this is the sign convention we need to follow. This is the sign convention we need to follow. That is anti-clockwise is positive. Sir, I am not able to understand it. Now see, we are differentiating with respect to x. If we are differentiating with respect to x and we are reaching to u, we are reaching to y direction velocity. So from x to y, is this rotation anti-clockwise? Is this rotation is anti-clockwise from x to y? Yes or no? Yes or no? Yes or no? Please tell me. Yes or no? We are differentiating with respect to x and we are reaching the velocity in y direction. So from x, if I go to y, I'll be making an anti-clockwise move. I'll be making an anti-clockwise move. Yes or no? Yes or no? Yes, sir. We are making an anti-clockwise move. Okay, so that is why I have put positive here. And when it is to be written positive, then nothing to be written. Now, if you see why I have written negative here. Now, from y to x, if I have to come from y to x, shall I be moving in clockwise direction? Now, if anti-clockwise is positive, clockwise should be taken as negative. Yes or no? Yes or no? Sign convention. This is the sign convention. As the sign convention we see in strength of material also, which is also common for mechanical and civil. Is it or isn't it, beta? Stream function is, as I said, it is in two dimensions. So if you see like this, y and z, you can write the stream function the same way. You will differentiate with respect to y. You will be getting the velocity in z, that is w. Is it any problem? Any problem? Raj, please tell me, any problem with that? Any two, yz you can take, yx you can take, zx you can take. Okay, the same way you can follow. Same way you can follow. Now, please tell me, if you will be given a stream function or velocity potential function, you will be able to calculate. You will be able to calculate u, v, w, and from there you can calculate anything that is asked. Yes or no? Anything that is asked. Yes or no? Yes or no? So in this sport booster sessions, beta, we are taking care of the numerical. Now, some theories also there. Some theories also there. That's what is the function of streamline potential line equations. So a streamline is a line along which a stream function is constant. Potential line is a line along which potential function is constant. Now, can we write something like this? D phi is equal to del phi by del x. By using our understanding of mathematics, can we write something like this or not? Can we write something like this or not? Tell me. Can we write something like this or not? Please tell me. Any issue with that? Any issue with that? Please tell me. Please tell me. Please tell me. No, sir. Now, if your potential line potential function is constant, so this will be 0. You can place the value of del psi by del x, del psi by del y in this equation. You will be getting a stream potential function equation. You will be getting potential function equation. Yes, on a potential line equation. Similarly, you can get a streamline equation. Then there is some theory there. There is some theory there. What is the theory? Sir, if potential function satisfy the Laplace equation, it will be steady in compressible flow. That also you can derive from all this. Okay. So in this school booster session, what I tried to tell you is how to manage with these formulas. How can you memorize them for a long? Yes or no? Yes or no? Now, is this clear? Is this clear? Fluid kinematics is clear up to this point or not? Please tell me. Is this clear up to this point or not? Please tell me. All of you. All of you. Now, can we say this is also clear? This is also clear? Yes or no? Yes or no? Now, sir, we are left with this fluid dynamics. So in this fluid dynamics, see, we are not going to see this compressible flow here. Why, sir? Why is that? Because compressible flow I taught na yaar. Steam turbine, gas turbine. See the GATE Academy videos. There also I have taught. Also this compressible flow is not there. Also this compressible flow is not there. Also this compressible flow is not there in civil syllabus. So we are not going to deal it here. If you want to see this compressible flow, go and watch steam and gas turbine. Okay, steam and gas turbine, the GATE new syllabus edition. In that also we have completed this compressible flow. Okay. And this is only for mechanical, so we are not going to do this in this combined session of civil and mechanical. Okay. Now this Bernoulli equation, pipe flow, vortex motion is nothing but this Bernoulli equation. Now, yes, that YouTube 6-day series it was. Yes, sir. Yes. So in this Bernoulli equation, pipe flow, vortex motion, these are nothing but the application of this Bernoulli equation. Nothing else. Nothing else. And let me tell you, Bernoulli equation is something that helped us. Okay, Harsh, we'll see. We'll see if we can take this fluid machinery. We can see. Okay, we can see. Okay. So listen. What I was telling. I was telling that this Bernoulli equation is the equation that help us in passing the semesters also. No need of see what we do. I tell you, never leave this machinery thing. Okay, I can teach it in 3-4 hours. Only one simple page concept is there. Those who have completed fluid mechanics with me previously, Must remember this. Okay, in fluid machinery, whole in one page I completed. Okay, and then we can see. Then we can see. Yes or no? Yes or no? So do not leave it. Okay, it's the simplest thing. Very simple. Now let us now conclude this session so that we can see in the next session. We can see each other in the next session. Now, what I was saying that this Bernoulli equation is very easy. It helps us passing the semester if you can relate to it. Yes or no? All of us who have passed this fluid mechanics semester examination must understand this feeling or not. Okay, so one session, do not feel this way, sir. One session is more than sufficient for covering all this topic. So do come, okay? Do come in the next session also, okay? So will you come or not in the next session, the last score booster session? And I'll certainly try to touch this fluid machinery if possible. If possible, I will definitely try to touch it. All right. So I hope all of you have liked this session. I hope all of you have liked this session. Yeah. So Vijay, for this timing and everything, you can go for timing and everything. You may consider, you may go for liking and subscribing the channel. If you guys have liked, if you all have liked and subscribed the channel, you will get all the notifications. You will get all the notifications. So I hope that all of you have liked the session. Okay. So in case of any feedback, any suggestions, any queries, you may contact the GATE Academy. You can see the details on the screen. Okay. So thank you very much. We will be seeing each other in the third and the final score booster session of fluid mechanics. Okay. So thanks a lot. Please do like, share, and please give your valuable feedbacks. Thank you very much.